Hello everyone, welcome you all to today's LeetCode video. And today we are going to discuss a question on LeetCode that is of bi-weekly contest 161. This is question number 2 of that contest, in which we have given a matrix of m cross n dimensions and a positive integer k. An island is a group of positive integers representing land that are 4 directionally connected, horizontally or vertically. The total value of an island is the sum of the values of all cells present in that island. We have to return the total number of islands with a value divisible by k. That means we have some islands present in our grid and we have to return those islands which are divisible by this k. Look at this example number 1. There are total 4 islands present in this example number 1 that is represented by the colors red and blue. Among these 4 islands, only 2 are divisible by this k equals 5. So we have to return 2 as our answer in this example. Looking at the example number 2, we have total 6 islands present in this example number 2 because islands are not connected diagonally to each other. So these 6 are considered to be distinct, and all these 6 islands are divisible by this k equals to 3. So we have to return 6 in this case. Now, what could be the brute force or the optimal solution to solve this? We have to just find out the islands. For every island, we can check that the total value or the total sum present in that island is divisible by this k or not. If the total sum present in that island is divisible by this k, we can increment our counter to keep track that how many islands are basically divisible by this k. So we can use DFS or BFS to solve this problem, but we are going to solve this using DFS. So let us look at this. This is example number 1 given to us. We have to solve this using DFS so we can keep track of the visiting cells, that which cells are previously visited or not. Using this visited array of type bool, basically this is a 2D boolean array that are initialized by false on every grid, like this, false on every grid. Now what we have to do now, we have to simply start a loop for I equals to 0 from here, and for every I equals to 0 less than I equals to less than n, like this, and then we have to traverse for j equals to 0 till j is less than m or the column size. Now for every I comma j, we have to check that whether this cell is previously visited or not. If it is not previously visited, we have to call our DFS function, and with that we have to also take care that the given cell is a land cell. That means the given cell have a value greater than 0. So we can ignore this, and our j is incremented and comes on this cell, and we can check that it is not visited yet. That means it is marked as false in visited array, and it is basically a land cell because it has a value greater than 0. So we have to call our DFS function for this cell, and in a single DFS call we can keep track that how many cells are connected to this cell in the 4-directional order. That means left, right, up and down. And in single DFS call it will mark all the cells that are connected to this cell in 4 directions. So let us see something. For every cell, what could be the coordinates of just above cell of that? Suppose this is r comma c, so the coordinates for the just above cell will be r minus 1, and this is same column, that means c, because it is in the same column but the row is decremented by 1, and this is up for up. For right, the coordinates will be, the row is same but the column is incremented by 1, that means r c plus 1, and this is basically for right direction. Now for down direction, the row is incremented by 1 but the column is same, row is incremented by 1, that means r plus 1, and c is same. This is for down direction. And for the left direction we can see that the row is still same, that means r is same but the column is decremented by 1, so c will be c minus 1 this time, and this will be for left direction. So we can make a 2D integer array to keep track of the up, right, down and left cells for every cell. That means this minus 1 comma 0, and then 0 comma 1, then 1 comma 0, and then 0 comma minus 1, like this. This array will keep track of all the 4 cells for every cell. Now when we are on this I comma j, we check that it is not previously visited. Yes, it is not previously visited and it has some value, that means it will be a part of some island, so call DFS for this I comma j. And when the DFS will called for this I comma j, what we have to do inside our DFS, let us suppose a DFS function will call for this I comma j, so the DFS will go into the call stack like this, and here the DFS will called. Let us increment the thickness of this call stack. Here the DFS function is called, and for this DFS function this I or this row will be 0 and this C or J will be 1. Now this visited array and this grid is passed into this DFS function using references, so we can keep track of the previously visited cells or not. Now what we have to do inside this DFS? First we have to mark this cell as visited. Mark this as visited. Now take the value of this cell in some variable. That means this sum will contains the value of this current I, j or r, c, like this. Now after doing this, we have to move for every adjacent cell of this too. So we can start a loop for I, or we can say that for j equals to 0 till j is less than 4, or j is less than this dir's size, and here this dir size is 4. Every time this j is incremented, we have to find the new nr and nc, and nr will be the previous r plus this dir's of j 0. That means, and nc will be the previous column plus dir's of j of 1. Now r is 0, c is 1. So first the nr will be 0 plus minus 1. That means minus 1. And nc will be 1 plus 0. That means 1. So these are the new coordinates that are basically for up of this cell, and we can see that these are not valid coordinates for this, because for this cell we cannot go up. So reject the above coordinates. That means we have to reject these coordinates. We cannot go into left because it is not a land cell, so we have to reject the left coordinates as well. We can go either right or left. So let us suppose we first go into the right direction. That means these. So after going into the right direction, we move here and we call our DFS for this cell. For this cell, we have to mark this as true, and then we will take the grid of r, c in some variable. That means here, and that will be basically 1 this time. Now for this cell we have to move into the 4 directions of this cell. We cannot move up, we cannot move right, left, because it is previously visited. Here we can see that it is visited. We cannot go into the right of this cell because it is not a land cell. We cannot go to the down of this cell because it is not a land cell. So for this one, all the possible 4 directions are basically visited, or we cannot go into these 2 directions. So callbacks to its previous DFS, returning this sum, that means this one. Now for this cell, this 5 is basically remaining, or this down direction is remaining, as we can see here. So for the down direction we have to mark this as visited, take the value of this 5 into some variable and try to move to all of its connected cells that are basically not previously visited and are the part of this island, that means have value greater than 0. And we can see that we cannot go here, we cannot go down, we cannot go right, and we cannot go up as well, because this 2 is previously visited. So this 5 is returned to its parent call, and in this parent call basically this 2 plus 1 plus 5, that means 7, 8. This 8 is returned to the call that is made in this for loops, and we can save the value that is returned by this DFS function in some long variable, and after one DFS call our island is marked as visited. So we can check if this value is, that means if this value is divisible by this k or not by modulus operator. If it is divisible by this k, we can increment our counter by 1, and finally when this for loop gets over, we have to return our CNT to the caller. Now let us code this and check if it is fine or not. First we have to make a vector of vector for the directions. -1, 0 for up, 0, 1 for right, 1, 0 for down, and 0, -1 for left. And now we have to make our DFS function that returns df long answer r, c to keep track of the current cell, suppose this one, and then this grid is passed by reference. Then we have to pass a boolean array to keep track of the visited cells, and then the dimensions n cross m. N represent the row size and m represent the column size. Now when we come inside our DFS, first thing we have to do is mark the current cells as visited, and then take the value of current r, c in some variable. Now after doing this, we have to move on 4 directions for every cell, and those 4 directions are basically comes as up, right, down and left. So the coordinates for new nr will be the previous r plus dir of 0, and the new column will be the previous column plus dir of 1. Now we have to check that whether these nr and nc are valid coordinates or not. It should have a value greater than equals to 0, and nr should less than the row size, and nc should have greater than equals to 0, and nc should have less than the size, that is column size. Also, the nr and nc are not previously visited, and the new nr and nc will be a part of this current island. That means they must have some value that is greater than 0. If all these conditions are satisfied, we can say that this nr, nc are the part of our current island group. And if these are the part of our current island group, we have to save the value of the current nr, nc in our sum variable. That means like this, we can call dfs for nr, nc. Now we have to finally return our sum that represent the sum of our current island. After doing this, we can write our main logic here in our count island function. First we have to take the size, this is row size, and m is column size. Now we have to initialize it to the vector of boolean named as visited to keep track of the previously visited cells. Now we start a loop. Also we have to initialize a counter variable to keep track that how many islands are basically divisible by this k. Start iterating over grid. Now if the grid is previously not visited and the cell has some value that is greater than 0, in that case we have to call the dfs for that cell. So call dfs for I, j and pass grid, visited, and the dimensions of the grid, and finally check that the total value of the current island is divisible by this k or not. If it is divisible, we have to increment our counter, and finally we have to return our counter variable. Now let us run this and check if it is running fine or not. It is running fine, so let us submit this. It does passes all the test cases, so Thank you so much guys, and please like and subscribe to this YouTube channel.